What makes this bicycle frame so light, enabling this cyclist to cover great distances? What gives the metal on this motorcycle its shiny luster? And what enables the computer chips in this computer to process information so quickly? The answer lies in substances called minerals. We use minerals every day. When you write using a pencil, you're using a mineral called graphite. When you put coins in a soda machine, you're using minerals. When you eat food, you're eating minerals. And when you take vitamins, you're providing your body with minerals needed to carry out everyday activities. During the next few minutes, we're going to take a look at some of the properties of minerals and see how minerals affect our lives. During the 1840s and 1850s, thousands of people came to this area from all parts of the globe in search of a precious mineral. You decide. What was that mineral? Gold. In fact, there was such a craze of people and activity that they called it the gold rush. Many people did strike it rich searching for this mineral, but most did not. But in the process, towns were built and the West became populated. What is it that makes gold and other substances minerals? A mineral is a natural inorganic substance. In other words, minerals are formed in nature, and they're inorganic, which means they're not made from living things. A rock is a material from the earth that is made of one or more minerals. Minerals are solids, with some, like corundum, being quite hard. Minerals also have a definite chemical composition, or makeup. Quartz, for example, is made up of silicon and oxygen. We'll take a look at the chemical composition of minerals later. Minerals also have definite crystal structures, which we'll also take a look at in a moment. Believe it or not, every time you sprinkle salt on your food, you're eating miniature cubes. Salt, as seen under the microscope, is made of small crystals in the shape of square cubes. A crystal is a solid in which the atoms are arranged in a pattern that repeats itself. This diagram of salt shows how the atoms arrange themselves in a cube. Most minerals, such as this sulfur, have a definite crystal structure or pattern in which the atoms are arranged. The crystalline structure tends to give the minerals their shape, as well as many of their properties. Let's now take a look at some of the different shapes of crystals. While there are thousands of different kinds of minerals, most fall into a few different crystal shapes. Each group of crystal shapes is referred to as a crystal system. We already took a look at how salt, or halite, has a cubic crystal system. Pyrite, or fool's gold, also has a cubic crystal shape. The beautiful crystals seen here are quartz crystals. Quartz crystals have a hexagonal shape. Other crystal shapes include orthorhombic and monoclinic. Each crystal system is defined by an arrangement of 3 or 4 lines called axes. You decide. What's the name of this place? Here's a hint. It's the hottest, driest, and lowest place in North America. This is Death Valley, California, 282 feet or 85 meters below sea level at its lowest point. Daily high temperatures commonly exceed 130 degrees Fahrenheit or 54 degrees Celsius. On a good hot day, it's possible to fry an egg on the hood of a car. Animals, such as this roadrunner and this coyote, must be able to survive in a place where food and water are scarce. But on occasion it does rain, and water accumulates on the long, flat valley floor. The mineral-laden water quickly evaporates under the hot sun, leaving behind these white crystals containing salt, gypsum, and calcium carbonate. The method by which these crystals form is called evaporation. When the water evaporates, the minerals stay behind in the form of crystals. If you were to leave a container of salty water on the shelf until all the water evaporates, eventually you would find small crystals left behind. Another method by which minerals form is from solutions which are saturated with dissolved minerals. These large structures were formed underwater in this lake when the lake was much higher. The lake water is saturated with dissolved substances that include calcium and carbonate seeping from underwater springs. These substances form calcium carbonate, a whitish limestone deposit that forms these large towering structures. Similarly, rock candy forms in solutions saturated with sugar. Over time, sugar crystals formed on this thin stick in the solution. Minerals formed in solutions are commonly found in the oceans and in other bodies of water, such as hot springs and geysers. Another way crystals form is from hot molten rock. You decide. What's the name for hot molten rock? If you said magma or lava, you're right. As magma cools, atoms rearrange themselves and lock into place, forming crystals. The kinds of chemicals in molten rock determine the type of crystals that form. The rate at which molten rock cools determines the size of the crystals. When molten rock cools slowly, larger crystals form, as is the case with granite seen here. But when molten rock cools quickly, smaller crystals develop, as in basalt seen here. Let's now take a look at the chemicals that make up minerals and some of the different mineral groups. Have you ever picked up a stone and skipped it across a pond? Chances are that stone contains silicon and oxygen, the most abundant elements in the Earth's crust. An element is a chemically pure substance made of just one kind of atom. Some minerals, such as sulfur seen here, are made of just one kind of element. But most minerals, such as azurite, are made of two or more elements. While there are 90 elements that naturally occur in the Earth's crust, about 90% of the weight of the crust is made up of only 8 elements. This chart illustrates the distribution of some of the major elements found in the Earth's crust. The two most abundant elements are oxygen and silicon, which make up nearly 3/4 of the Earth's crust. Other elements such as aluminum, iron, calcium, and sodium make up a much smaller percentage of the crust. Minerals tend to be grouped based on the elements they contain. Silicates, for example, are minerals that contain silicon and oxygen, as well as one or more other elements. Quartz is a silicate. Quartz is often used in watches. Mica, another silicate, is often used in wallpaper to give it a shiny luster. And feldspar, often used in the manufacture of porcelain, is another example of a silicate. Some minerals, such as this calcite, contain carbon and oxygen and form carbonate or CO3. Minerals, such as those found in these stalactites, are referred to as carbonate minerals, as are those found in this limestone, which contains these fossils seen here. Prospecting for gold is not an easy task. As water comes into the pan, the prospector is looking for certain properties or characteristics. All minerals have properties that can be identified. Most mineral properties you can identify on your own with no special equipment. Back to our prospector. One property he's looking for is color. Gold is a gold-yellow color, but so is another mineral called pyrite, a mineral not as valuable as gold, therefore often called fool's gold. Sometimes when minerals are rubbed against something, they leave a mark or streak. The color of the powder left on a streak plate is called the streak. Sometimes a mineral streak is different than the color of the mineral. For example, gold has a gold streak, but pyrite has a black streak. Luster is another property used to identify minerals. Luster is the way a mineral reflects light. Some minerals, such as galena, have a shiny metallic luster, while others, such as talc, have a duller, non-metallic luster. The way a mineral breaks can also tell us a lot. There are two main terms that describe how minerals break. Cleavage occurs when minerals split along flat surfaces. This muscovite cleaves along smooth, flat surfaces, and this halite breaks into flat cubes. Most minerals, such as quartz, do not break along smooth, flat surfaces. Instead, they break along jagged surfaces. This is called fracture. You decide. Which rock do you think will float? As you can see, the rock that was on the left, called pumice, floats. This is because it is less dense than the piece of copper. Density is the amount of matter in a space. The density of minerals is often measured using specific gravity. Specific gravity is the ratio of a mineral's density to the density of water. For example, galena is a relatively dense material with a specific gravity of 7.5, meaning that it is 7.5 times denser than water. But quartz only has a specific gravity of 2.65, a little more than 2.5 times the weight of water. The last property of minerals we'll discuss is hardness. Each mineral has a specific hardness. For example, talcum powder is made from a very soft mineral called talc. This saw blade contains diamonds, which is so hard they're able to slice through rock. To compare the hardness of minerals, a scientist by the name of Friedrich Mohs developed Mohs' scale of hardness, seen here. The scale contains 10 minerals of different hardness. Talc is the softest, symbolized by 1, and a diamond, symbolized by the number 10, is the hardest. These colorful minerals are considered gems. A gem is a highly prized mineral. Gems tend to be brighter and more colorful than some samples of the same minerals. For example, this purple amethyst is considered a gem, even though it's made of the same general mineral as quartz. Different kinds of gems include diamonds and garnets, seen here. You decide. What's the main mineral found in the Golden Gate Bridge? It's iron. Iron used to make steel is a very important mineral. Iron is most often used as ore. An ore is a mineral or rock that has usable amounts of metal. Copper, another very important mineral used on roofs and in wiring, also comes from an ore mineral. During the past few minutes, we've looked at some of the different characteristics of minerals and their uses. We took a look at the structure of minerals by looking at their crystal shapes and how crystals are formed through evaporation or the cooling of hot molten rock. We also looked at some of the elements which make up rocks and minerals. We explored how you can identify different minerals by looking at their properties, including color, luster, breakage, density, and hardness. Finally, we took a look at some of the uses of minerals. So, the next time you look at a mineral, put salt on your food, look at your watch to check the time, or drive over a bridge, think about all the different characteristics of minerals and the way they affect our lives. You might just look at your world a little differently. Fill in the correct word when you hear this tone. Good luck, and let's begin. Number 1. A is an inorganic substance. Number 2. Salt consists of crystals shaped like. Number 3. Each group of crystal shapes is called a. Number 4. The crystalline structure tends to give minerals their. Number 5. An is a chemically pure substance made of one kind of atom. Number 6. Lava or magma is derived from rock. Number 7. Are minerals that contain silicon and oxygen. Number 8. The way a mineral reflects light is called. Number 9. Occurs when minerals split along flat surfaces. And number 10. When rocks break along jagged surfaces, it's called